Hey folks, this is chapter 1, lesson 6. We're going to begin with a tiny bit of review that's important for this lesson. Find the length of the hypotenuse of this right triangle. Ask yourself what formula you're going to have to use here. You're certainly going to have to use Pythagorean theorem, right? What is that formula going to be? It's going to be the base squared plus the height squared is the hypotenuse squared. How are we going to calculate the length of the base? Right minus left. How are we going to calculate the length of the height? Top minus bottom. All right, now it's just about our plugging in numbers. 17 minus 2 for the base, 10 minus 3 for the height. We get this, square both sides, and you get the hypotenuse squared is 274. Since we want the actual hypotenuse, we take the square root. All right, key here is remembering whenever I want to get a length in R2, length of hypotenuse of a right triangle, it's the base squared times the height squared. Okay. This is the same question, except it's now happening on a Cartesian coordinate plane. It said find the distance in R2 between C and D. Only now you need to plot the points, C and D, put a distance between them, and then imagine that there's a right triangle. In R2 on a Cartesian coordinate plane, that right triangle is always embedded since the axes are in right angles. All right, so how are we going to get that distance CD? Same thing, Pythagorean theorem. Hypotenuse squared is base squared plus height squared. Right minus left for the base, and top minus bottom for the height, right? So that's the same thing as x2 minus x1 and y2 minus y1. Now, look at it. You got 5 minus negative 4. You got 1 minus negative 6. All right, and don't forget when you've got that length squared, you need to square root both sides so you get the actual length. Now, you will need this in your lesson today, so let's get into it. Chapter 1, lesson 6, two-dimensional figures. All right. A polygon is a closed figure formed by a finite number of coplanar segments called sides. All right, let's break this down. A closed figure means a figure that's not open. This is closed, this would be open. By a finite number of coplanar segments. If you look at this polygon there's a picture of here, it's clearly on one plane, namely the screen you're looking at right now. And each of the line segments are called sides, like side GH is a line segment. And such that the sides have a common endpoint and are non-collinear. Well, do you see that GH and HJ have a common endpoint H? Can you also see that GH and HJ are not on the same line? They're not non-collinear. All right, each side intersects exactly two other sides, but only at their endpoints. Each side intersects exactly two other sides. You see the side right here, GH, it intersects GM and HJ, but only at the endpoints. All right. The vertex of each angle is a vertex of the polygon. G is a vertex, H is a vertex, J is a vertex. And to name the polygon is named by the letters as vertices written in consecutive order of letters. So maybe we go G, H, J, K, L, M, and that's just the name of the polygon. All right, here's some examples of polygons and non-polygons, and I want you to think about or write down 3 observations about polygons that distinguish them from non-polygons. You can pause the video now if you want to think about it. All right, clearly if you look at the not polygons, we have some that have are open, not closed. We have some with wavy lines as opposed to line segments, and some that kind of cross over themselves. Even extended lines here, none of that's acceptable in polygon land. Polygon, you have to closed figures. They have to be made up of line segments of the outer portions. Polygons can be concave or convex. Suppose the line containing each side is drawn. If any of the lines containing any point in the interiors of the polygon, then it is concave, otherwise it's convex. So look over here. If you extend these segments into lines, none of the lines cross through the interior of the polygon. But this non-polygon over here, or this concave polygon over here, If you extend the lines, especially these two lines right here, those lines will actually penetrate into the interior of the polygon. It almost looks like the polygon's been caved in right here, concave polygon. Polygon is classified by its number of sides. A polygon with n sides is an n-gon. For example, a 12-sided polygon is a 12-gon or dodecagon. All right, what you see here is called a pentagon because it has 5 sides. You have to learn this table. 5 sides, pentagon. 6 sides, hexagon. 7 sides, heptagon, and so on and so forth. This table is in your book. You learn and memorize them. They will come up throughout the year, so you just need to know them. Now, if you have a 4-sided figure, you're probably thinking, ooh, that must be a rectangle. Okay, well, more generally speaking, quadrilateral, that's what we call it. All right, a 12-sided figure might call it a 12-gon or a dodecagon. An equilateral polygon is a polygon in which all the sides are congruent. Here you see these tick marks. These 5 tick marks indicates that the pentagon has all congruent segments. It's equiangular if all the angles are congruent. These have the same number of arcs, those are congruent. A convex polygon that is both equilateral and equiangular is called a regular polygon. Otherwise, it's irregular. What makes this regular? It's got congruent sides, equilateral. It's got congruent angles, equiangular, and it's convex. Remember, if you extend the lines, none of them penetrate into the interior. All right, so you want to write down 3 observations about regular polygons that distinguish them from irregular polygons. You can pause it now and give that a shot. All right.
Here's an answer for reference.
That's nice. All right, once again, we got congruent sides, equilateral. We got congruent angles, that's equiangular. And then finally, convex. Name each polygon by its number of sides. Then classify it as convex or concave, regular or irregular. Let's try it out. All right, what do we think about this one? How many sides does it have? 1, 2, 3, 4, 5, 6. So that makes it a hexagon. You just have to memorize those terms. Let's see. Is it convex or concave? Well, you can see that these lines right here are going to penetrate to the interior, which means it must be concave. And then finally, well, if it's concave, it's definitely irregular because you have to be convex as a precondition. All right, here we have congruent sides, we have congruent angles, it's convex, no penetration to the interior, so we have a regular polygon. And how many sides does it have? 1, 2, 3, 4, 5, 6, 7, 8, so it's an octagon. It's an octagon that's convex and regular. Want to try these? All right, let's try these. You might want to pause it here and see what you get. All right. So you might be tempted to call this a rectangle, and while it is a rectangle, a 4-sided polygon is called a quadrilateral. It's a more broad category. All right, is it concave or convex? Convex, right? And it is not regular because it is not equilateral. How about the star? How many sides does that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Therefore, it is a decagon. Deca means 10. It's concave because these sides penetrate. It is irregular, therefore. And the final one is a hexagon, equiangular, equilateral, convex, therefore regular. All right, we have to know how to take the perimeter of a polygon. The perimeter of a polygon is the sum of the lengths of the sides of the polygon. The circumference of a circle is the distance around the circle. All right, so the length of the outer portion of the triangle is its perimeter, outer portion of the square is its perimeter. The outer portion of the circle is called its circumference, which is its perimeter, but because the circle is not a polygon, it's got a different term called circumference. You have to know these formulas, and you probably have counted them already. How do you get the perimeter of a triangle? Add sides B, C, and D. Those are just names. How do you get the perimeter of a square? Add the outside. There's 4 S's, so it's, just remember its perimeter is 4S. Rectangle perimeter is 2 lengths, 2 widths, and the circumference of a circle is 2 pi r or pi d. D is the diameter of a circle. It goes through the center and it goes from end to end, right? A radius starts in the center and goes to an end. So it's half the distance of a diameter. So you can either say 2 pi r or pi times the diameter. You need to know both definitions. Area of a triangle, 1/2 base times height, square or rectangle. Well, square will be side times side or side squared. Rectangle, base times height or length times width. Area of a circle, pi times the radius squared. Very important to know what these things are. The area of a figure is the number of square units needed to cover the surface. All right, when we talk about perimeter, we're talking about something that's one-dimensional. Do you see C, B, and D? I could take that outer distance there and put it into a straight line. I could take these 4 segments and lay them out in a straight line. I could take these 4 segments, lay them out in a straight line. I could even take the circle, make a little cut in it right here and bend it so it becomes a straight line. So it's got a one-dimensional measurement, units. But area could never be done in one dimension. Area is the surface that you're covering. So it must be in 2-dimensional space, and therefore you need square units. Square units always for area. All right. Find the perimeter or circumference and find the area of each figure. All right. It's a rectangle. How are you going to find its perimeter? Yeah, add up the 4 sides. So twice the bottom plus twice the side. Great. Now, the units are just going to be one-dimensional, centimeters, because perimeter, once again, I can take the 4 sides, kind of make a cut right here, and then lay it out as one long line. So essentially it can exist in R1, it's one-dimensional. Look how I laid this out. Formula for perimeter calculation by plug and chug, and then finally answer with units. That's how you should do it. Area, base times height, length times height, plug and chug, and answer with units. Notice the square units for area, because you're in R2, definitely with area. All right, how about for a circle? Is it perimeter? No, it's circumference. Here's what we call it. And what was the formula for circumference? 2 pi r. The radius you can see is 3 inches. So, okay. So circumference is 6 pi inches, one-dimensional, which is approximately 18.85 inches when you put it in your calculator and round it to 2 decimal places. Area, pi r squared, 9 pi inches squared. Make sure you get square units for area. And then here's your estimate. All right, why don't you try these? You can pause it and get the perimeter and circumference and area of each. All right, so here's what you should have got for perimeter, an area of a square. A rectangle, it's a rectangle, it's not a square. It might look like a square. We see 6 feet, 5.5 feet, definitely a rectangle. Don't use the square formula, get things wrong here. Once again, equation, plug and chug, answer with units. Equation, plug and chug, answer with square units. And here are your answers for a circle and for a triangle. You know, with triangle, for some reason, sometimes perimeter confuses folks for whatever reason. Perimeter is always just this outer chunk. You just want to add together the length of this segment, and this segment. We're just calling it B, C, and D. You call it A, B, and C. Call it S1, S2, S3. It doesn't matter. And then area is 1/2 base times height. All right, learning to read your math textbook is a skill that will help you immensely in this class and in future math classes. Most of you at this point have realized the value of reading your textbook and have started reading it. I advise you, if you're struggling, that you read your math book every day, that you read it like a little bit, at night, maybe before you read your Bible for bedtime, or maybe read it in the morning right after you read your Bible. Right? God's word comes first, but math is also a language of God, and you can think his thoughts after him. So I would have you read from your math textbook. If that seems odd to you, if that seems foreign to you, let me tell you, it's a great skill that will help you in this class and help you in future classes. In part, it's going to increase your learning. 2, it's going to help you to become more of a self-learner, which is a great skill to have in life. And it's going to make you much more familiar with the content and the examples. So when you go do your homework, you will always see and have read the examples and kind of know where to look back for what you need to do your homework problems. So I want you to read example 3 from your textbook to yourself and sketch down any questions you would have. Now, in class, we had this discussion with small group members, try to get those questions asked. If you still have questions after you've written them down and kind of thought about it, maybe talk to your parents about it or a friend about it, feel free to come to me during lunch or after school if you were absent and are reviewing this, and I'd be happy to help you. All right. In class, we did the same thing with example 4. So you want to turn to page 60 and read example 4 carefully, and then come up with any questions you have. You can go ahead and do that now and pause the video. I will go over this problem together within the slideshow. Okay, let's go on to example 4. So here's example 4 in the textbook. We're given this, clearly it's a square. Say, how do you know it's a square? Well, you see the right angles, so we know it's equiangular. You see it's convex, so we know it's a regular polygon. But what's more to it, if you count the distance from here to here, right minus left, 5 minus -1, you get 6. If you count the distance here, what do you have? You have 2 minus -4, which is 6. So these right here form perpendicular lines that are equilateral. So this is going to be a square. So the question is, how do we get the perimeter of the square and the area of the square? How do you think you're going to do that? Well, you're definitely going to have to get the length of the sides. Really, you just have to get the length of one side because this is a square. Once you have the length of one side, you have all the lengths. So how can we do that? Well, that's why we continue to practice the distance formula in R2. How do we get this length right here between two ordered pairs? Do you remember? First thing you do is drop the right triangle, and you're going to use what theorem? The Pythagorean theorem, exactly. So how do we get the base? It's going to be right minus left, or 5 minus 2. If you're trying to 5 minus 2. How about the height? It's going to be 2 minus -1. 2 minus -1. All right. So we get that BC squared is 18, therefore the length BC is squared is 18. Now what do we want to find? Perimeter? Well, it's a square, so 4 sides, lengths, 4 squared is 18. That's the perimeter, which is 16.97 units. One dimensional, so just units, not units squared. Area, that's a square, so side times side in this case. Base times height, side times side. That'll certainly do the trick. Side square of 18, square root of 18 squared. The square root and the square cancel each other out because they are inverse functions, and you get area equals 18. Because it is a two-dimensional measurement that can only occur in R2, it can't be broken down to R1. It's going to be units squared, a two-dimensional unit. All right, folks, here's your homework, 13 through 51 odd. 13 through 51 odd. If you have any questions, you always see me during lunch or after school. Have a good one.